number 3, site of infections, and the patients. Let me show you this, how to evaluate antibacterial efficacy using pharmacokinetic and pharmacodynamics. You know that pharmacokinetics is talking about the serum concentrations, how long it will achieve the peak concentration, and how long it will be eliminated from the body, and how it will penetrate to the site of infection. But pharmacodynamic will tell you the susceptibility, the antibiotics and then concentration, whether the antibiotics and concentration or antibiotic killing, and then about persistent or post-effect antibiotics. Yeah, this is the way pharmacokinetics tell us. Every drug, if you take orally, it will be absorbed and then distributed and then metabolized and then excrete. There are 2 things. You keep the antibiotics, which is the peak, keep the peak high, especially antibiotics such as aminoglycoside. You need to take a loading dose to make sure that the peak is very high. But the second one, for instance, beta-lactamase, it doesn't need to the high, achieving high peak. But for beta-lactamase, macrolide, clindamycin, linezolid, you keep the durations of the antibiotic above MIC. The longer the antibiotic concentration above MIC, the better the result. And then this one is about the AUC-MIC ratio of 24 hours, which is represented by erythromycin, fluoroquinolone, and vancomycin. This is here, for instance, this is pharmacodynamic or concentration-dependent antimicrobial. What we need to do is make sure that the peak concentrations when it is given is high, compared to if you give it twice, so it will only achieve half of the concentrations and it will not work as what we expect. So the best thing to do is give it in a loading dose. This is, for instance, 500 milligrams every 24 hours compared to the 250 milligrams every 12 hours. So start with this one. What about the beta-lactamase? Beta-lactamase should be given, and you need to convince yourself that the concentrations above MIC is longer than compared to this 1 gram every 8 hours over 30 minutes, and this one 1 gram every 8 hours. You see here, the longer the time above MIC, better the outcome. What about the sepsis? I previously mentioned that oral antibiotics is no different in terms of outcome compared to the intravenous or parenteral antibiotics. It was true for common infection, but in sepsis, severe infections, you cannot use oral antibiotics. So what you're going to do, for beta-lactams, for instance, its elimination half-life about half an hour until 2 hours. This is time dependent. Make sure that antibiotic concentration exceeds the MIC 40 to 70% of the time. What about fluoroquinolone? It will be eliminated between 2.5 to 12 hours. This is concentration dependent. Make sure that AUC ratio MIC is more than 125, etc. Again, aminoglycoside, I mentioned previously, the concentration dependent, so maximum concentration at least 8 to 10 times the MIC. Meaning, you start with high concentrations on aminoglycoside. What does pharmacokinetics tell you, and also pharmacodynamics tells you. Pharmacokinetic tells you about time course of drug concentration in the body. Once it is ingested, and then it will be distributed, it will be metabolism, and then you will see after drug concentration, we are talking about the pharmacodynamics. What concentration has been achieved, in which area of infections, make sure that that concentration also achieving the site of infection. And then you will see clinical outcome. The most often question is that if we adjust dose, because patients have a problem with renal disease, for instance, whether reducing dose will achieve similar outcome, that's another issue. Reducing dose, meaning you reduce the risk of adverse event, but there is no such guarantee that reducing dose will end up with similar outcome compared to those without reducing dose. Oops. Yeah. This is another example of antibiotic tissue penetration. Make sure you know the source of infection. Otherwise, you treat your patient with antibiotics which cannot penetrate to the source of infection. For instance, fluoroquinolone, it's good, the tissue penetrations are good in LCS, renal, lung, prostate, bronchial, nose, gallbladder, gastrointestinal, urinary tract. If you cannot detect where does the infection is, where does the infection, for instance, patients with gallbladder infections, and then you prescribe clotrimazole, it won't work. It won't achieve the source of infection because it doesn't penetrate to the tissues. And then what about azithromycin? Its tissue penetrations are good in pulmonary, EMN, leukocytes, tonsillar tissue, genital, and pelvic tissue. Okay, clinicians quite often ask a question. If I have patients with bone infections, what is the best antibiotics to prescribe? Sometimes they prescribe vancomycin. You see, the penetration of vancomycin in the bone is only between 7 to 13%. So it is unlikely that you can speed up or you can kill the bacteria if bone infection in full, because anyway, vancomycin doesn't penetrate. Doesn't penetrate appropriately in the bone. Even though you can see here in sternal bone, the penetration is very good, 57%. Now you can also see linezolid penetrations in the bone, 40% to 60%. So you better prescribe linezolid if infections involve bone because it can penetrate to the bone. So if patients prolong hospitalizations because infections doesn't cure, maybe because you prescribe inappropriate or wrong antibiotics. Yeah, this is comparison tissue concentration between vancomycin and linezolid. You can see here in bone, much better linezolid. Cerebral spinal fluid, much better linezolid compared to vancomycin. And then epithelial lining fluid is much better in linezolid compared to the vancomycin, etc. and so forth. Yeah, I will skip this slide. So, key message number 1. Antibiotics are not for common. So, if you are not ready to detect that there is any bacterial infection involved, do not prescribe antibiotics. Key message number 2. Beta-lactams need frequent dosing for a successful therapeutic outcome. Missing doses will lead to treatment failure. So do not prescribe antibiotics twice a day, 3 times a day, 4 times a day. Start right now, not only antibiotics. If you would like to prescribe to patients, make sure you prescribe it 1 tablet every 8 hours, or 1 tablet every 12 hours, or 1 tablet every 24 hours, instead of 3 times a day, 1 time, or twice a day. Aminoglycoside should be given as large single dose, except in infective hepatitis, for a successful therapeutic outcome. Multiple small doses will lead to treatment failure and likely to lead to renal toxicity. If the use of aminoglycoside is unavoidable, and then make sure you start with high concentration at the beginning of the treatment. Otherwise, it will fail to treat your patient. Key message number 3, when selecting antibiotics, consider the following. Where is the infections? Make sure you know the source of infection. Second, which antibiotics will list the source of infection. And then match the two and select your antibiotics. Otherwise, we just prescribe antibiotics, but it doesn't work because it doesn't penetrate to the area where the infection is happening. Key message number 4, antibiotics, drug interaction, be very careful of prescribing penicillin together with concurrently with, for instance, methotrexate and allopurinol because it reduces excretion of methotrexate, tetracycline with rifampicin, carbamazepine, barbiturate, or other cytochrome P4, 5T inducers because plasma doxycycline levels will reduce and then no cure will happen. So be very careful of prescribing so many medicine concurrently. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.